Hello, this is the second part of the chapter 5.1, and we will talk about eigenspaces. And in the previous lecture, we discover that if lambda is an eigenvalue of our square matrix A, then the necessary condition for the eigenvalue to be is the product of matrix A minus lambda times identity matrix times X is equal 0. In other words, this matrix equation should have a non-trivial solution. And you probably recognize this condition as pretty much a definition of the null space for the matrix A minus lambda I. And we say that this null space is actually quite special. There is a lot of interesting properties based on this particular place of this particular matrix. So we call it the eigenspace of matrix A corresponding to the eigenvalue lambda. And you can easily prove that there is a subspace of Rn, and its subspace consists of the zero vectors and all the eigenvector corresponding to the eigenvalue lambda. And again, we remember that by definition, our eigenvectors cannot be zero, so we have to basically add this zero vector. And again, it probably does not sound like a big deal. So let's just try to find this eigenspace, calculate, experience it, and admire it, hopefully, at some point. But again, just experience and trying to solve problem first is probably a good strategy here, because admiration will come later. Okay, so we here have 3 by 3 matrix. So, and we know that the eigenvalue here, at least one eigenvalue, is equal to, and we don't know much about eigenspace. All we know that the eigenspace consists of some kind of vectors which correspond to our eigenvalue. And we know, though, that when we multiply those vectors by matrix A, we get vectors which twice longer. And this is just the basic definition of the eigenvector. Okay, so let's start with a definition. We know that our eigenspace, if vectors in the eigenspace are just satisfy our homogeneous equations for the matrix A minus lambda I, or it should be a null space for the vector A minus lambda I. So let's just calculate this matrix. We know that our eigenvalue is equal to, so we take our matrix A and subtract double of identity matrix here. And here we have a 3 by 3 identity matrix. And double identity matrix is just a matrix which has a diagonal, left diagonal value equal 2, and the rest is 0. So it's pretty easy to subtract. So we have this kind of nifty looking matrix. Okay, so let's just keep eye on our goal. We are trying to find the null space or set of eigenvectors here. So we need to solve this non-homogeneous equations, because we know that the null space is actually all the vector x which satisfy the matrix equation. Okay, so the easiest way to do it is just form augmented matrix and reduce it to the echelon form. Okay, this is our augmented matrix. The third column is 0 because it's a homogeneous equation. So, and the reduction to echelon form is actually pretty straightforward. We get 2 empty rows, which mean that there is at least 2 variables. Let's say x2 and x3 can be any variable out of 3 can be any out of 3 variables, any 2 of them can be free, but I'll choose x2 and x3. So we can write down our vector x, our eigenvector x, as the linear combination of 3 parameters, x2 and x3, and some kind of vectors. And again, because if you are not sure how we find those vectors, please go back to the basis for the null space chapter, part of the chapter 4, and repeat it. I'm not going to go through this because that's we done expansion of the basis several times in the previous chapters. But basically, we'll write down our x vector as a linear combination of free variables and two new vectors, which is form the basis for the space. And by the way, that's our eigenvectors, these two vectors. And because, like our x2 and x3 can be anything, and I don't like to have a fraction here, I'm basically take this first vector multiplied by 2 and form a little bit neater looking basis for our vectors. Okay, and that's it. I'd like you to go now to the end of the chapter and try to find the eigenvalues and the basis for the eigenspace for the couple of examples. It probably will be still confusing, but after you've done a couple times, you will start appreciate it more.